Greetings to you all. We'll be looking at integration by part in this video. Integration by part is used when we are to integrate a product of two functions, and we need to choose carefully which one to differentiate and which one to integrate. And to do that, we'll have to illustrate using some examples. Now, if you have two functions here, if you have a function and integral written as u dv, right, it means you will look how to differentiate a u, then dv, you will integrate it to obtain your v. So we are saying that the integral of u dv is uv minus v du. How do you, let's illustrate this with an example. Let's look at this example. Now we are asked to integrate x cosx dx, for example, right? Now we have to choose. I will choose to differentiate x. Why? Because when I differentiate x, the power will reduce, it will be 1. And I would integrate cos x. So this is my u. This will be my u. And my dv, all of this is my dv. Right? So this is what we have. U is equal to x implies when you differentiate du is equal to dx. Why is du equal to dx? Because if you have to differentiate this, du dx will give you 1. So du is equal to dx. Now integrating also, to have v, dv is equal to this. It means for us to have v is simply the integral of cos x dx. And when you integrate cos x dx, when you integrate cos, it gives us sine. We have sine x. So our v, we have obtained our v here, right? Now likewise here, so what will be the answer to our integral? The answer will be uv. It will be x sine x minus the integral of v du, and that's the integral of v du, which is sine x, which is sine x dx. So when you do that, you'll be left with x sine x. When you integrate sine, it gives you negative cos, and negative here positive. So you have positive cos a plus c, our constant of integration. Let's look at example 2. The integral of x ln x dx. Looking at the integral of x ln x dx. Here, in this case, when we have a logarithm, we take our logarithm as our u. So what we are doing here, we're going to do here, our u will be ln x, then our x dx will be our dv. Okay, what does that mean? It means u is equal to ln x, right? If I'm differentiating this, it means du dx is equal to, differentiate x is 1, so 1 over x, which implies here that du is 1 over x dx. 1 over x dx. That's our du. So we have our du. Then our dv. dv is x. dv is equal to x dx, right? So our v will be the integral of both sides here. We give us, to obtain our v here, we integrate both sides. And when we integrate x, if we are to obtain our v, we have integral here, integral. When we integrate x, we have x squared, right? So v is x squared divided by 2. Okay, having obtained the value, our v, it means this integral, the complete answer now, uv. Our u is ln x, then our v, x squared over 2. So we have x squared over 2 ln x minus the integral of v du. Integral of v, our v is x squared over 2, and our du is 1 over x. Our du 1 over x dx. du is 1 over x dx. So which gives us our du is 1 over x dx, our v is x squared over 2. So the final answer to our integral now will be uv ln x, which was ln x. So we have x squared over 2 ln x minus the integral v du. We have x squared here over 2 times 1 over x dx. Now having 1 over x here, this x here will cancel with this. We are left with 1x. So giving us as answer below, we have x squared over 2 ln x minus the integral here, minus the integral. When you integrate, after cancelling here, we have x here over 2. When you integrate x over 2, gives you x squared over 4 plus c plus your constant of integration. Okay, thank you.